protein to make.
No, the sequences tell you.
What was the original question you asked?
Does it still read the nitrogen bases before the AUG?
Well, yeah,
It reads them until it finds AUG, but they don't do anything.
Can you restate the question?
Why would you need nitrogenous bases in front of AUG? Why is it not just AUG from the beginning of messenger RNA?
Depends on
What are the two options of the protein being made? Where? Cytosol, endoplasmic reticulum? Where do you think the instructions for that are? Hey, ribosome, go to the cytosol.
Is it in the
Is that in the alveoli?
It's in that before, right? In addition to that, you got to think that messenger RNA has to come out of the nucleus and it's got to wade through the cytosol. It might have to go around a mitochondria. It might get a little broken, right? If it's going to get broken, it's going to get broken at the beginning of the end, right? So if AUG doesn't start till 50 codons in, if that first piece gets broken, whatever, it's before AUG. So that helps ensure that the message that needs to get to the ribosome has a higher chance of making it to the ribosome.
Oh, it's like a safety net?
It's a safety net,
So the first part is like, it tells where to make the protein.
right? Stay here in the cytosol or go to the rough ER, right? Okay, so small ribosomal subunit reads it until it finds AUG. Once it finds AUG, it knows I am ready to start making a protein. I need my amino acids. It's going to send a chemical message out to the cytoplasm that says, I have found start. I need the amino acid for start, which is methionine. Okay? Okay. Transfer RNA's job is to carry in the amino acids that the ribosome needs. So, there is a transfer RNA for every single codon. Right? There are multiple transfer RNAs for codon, but there is a transfer RNA just for AUG. And it has methionine, that's the AUG, right, amino acid. It has methionine on it. It holds it on its bottom, like on the tip of it, right? Okay? So, transfer RNA, I'm just going to make it a T because that's easier. Down here, it's got the amino acid for AUG, okay? And we abbreviate amino acids by 3 letters. If you look at your chart, you see they have a 3-letter thing next to them. Everybody see that? So if I want to write glycine, I just write GLY, right? Okay, so transfer RNA has the amino acid methionine on the bottom. On the top of it, it has the anticodon to the codon. And just listen to me and I'll give you time to write it down. Just listen. The anticodon is the complementary base sequence to the codon. The anticodon is the complementary base sequence to the codon. What's the complementary base to C? G. What's the complementary base to U? What's the complementary base to A? U. And the complementary base to C? G. So the anticodon for CUG is GAC. Yeah?
So does the anticodon bond to the
The anticodon bonds to the codon. So this transfer RNA comes in, right? CUG's transfer RNA comes in, and that anticodon this is the codon. This is the anticodon.
Oh, it bonds with it?
This whole thing here. That whole thing is the transfer RNA.
Okay.
It hydrogen bonds, yeah.
Alright.
Yeah. Okay? It hydrogen bonds to it. Here's your transfer RNA. There's the small ribosomal subunit. It's found CUG. This transfer RNA is coming in and it's going to bind to the codon. If, by some chance, the ribosome has misread the codon and it doesn't have CUG, it has CUA. Because that transfer RNA won't properly bond now, because C doesn't bond to A, the ribosome will go, oh no, that's okay. I misread. Get out of here, tRNA. I'm going to look again. And looks again. So this is just a backup system, right? It checks. Yeah?
What is the META at the bottom?
Methionine. That's the amino acid. That, yeah.
Oh, so that's how it knows what amino acid to bring is.
Well, every codon has its own transfer RNA that has that amino acid on it.
Okay.
Yeah?
Mhm.
So if you look at your chart, UUU, the transfer RNA for UUU is going to have the amino acid phenylalanine at the bottom of it and the anticodon AAA at the top of it.
Oh,
Okay? The transfer RNA for UUC is still going to have phenylalanine, but it'll have the anticodon AAG. Whose hand was up?
Oh, I was gonna ask. So it knows what the sequence should be because it read.
The messenger RNA doesn't know what the sequence should be. The messenger RNA, the ribosome doesn't know what the sequence should be. It just reads it out loud, and then the transfer RNA checks it.
So, but how does the transfer RNA know, like, if that should be there or not?
Well, the transfer RNA doesn't,
Oh.
right? Okay, let's do this example, right? So let's say this is our messenger RNA, and I'm a codon. I mean, I'm a ribosome, right? And I'm reading it, and I say, okay, this says 1 cup of sugar, right? Let's say we're making a cake, right? This says 1 cup of sugar, right? The transfer RNA for 1 cup of sugar would come in and look at this and would read the same thing I just read, right? And if the transfer RNA came in and said 1 cup of flour, I'd be like, oh, 1 cup of flour. Yep, that's not time to start yet, right?
Oh, okay.
So the transfer RNA didn't come in and say, you read that wrong, look at it again, whatever. The transfer RNA just came in and double checked me, read what I read. And if it didn't sound right, then I know maybe I haven't found what I think I found.
Okay.
And I reread. If this transfer RNA comes in and it doesn't bond in all 3 places, because maybe this said CUC, right? And so this wouldn't bond here. The ribosome knows, oh, okay, maybe it's not the start codon. Okay,
Okay.
let me reread it. CUC, oh yeah, no, that's not start. Yeah? You with me on that?
So if the ribosome thinks it started, but then the transfer RNA comes in and reads CUC, and the ribosome didn't do that, it tells
The transfer RNA goes away and the ribosome rereads looking for AUG, right?
And then another
Does
one.
so after this starts, do more and more transfer RNA?
Well, it's going to read it 3 by 3 and more transfer RNAs are going to come in, but we're not there yet. But yes. Okay. Everybody with me up to this point. The messenger RNA leaves the nucleus. It finds the small ribosomal subunit. The messenger RNA slides into the small ribosomal subunit. The ribosomal subunit starts reading it, looking for that start codon, AUG. Looking. I found AUG. I need AUG's tRNA. AUG's tRNA comes in, bonds its anticodon to the codon. If it's incorrect, the tRNA goes away, the ribosome reads again, the small ribosomal subunit. If it's correct, we'll start there on Friday.
Yes.
How fast does this go? Correctly, like,
About 30 seconds.
for
It's
the
actually-
entire process?
That's a lot shorter than I thought it'd be.
Yeah.
It'll be like a
If
few
you do
days.
go back to
Okay. As always, your homework is what?
Science
The
fair.
Science fair. Note cards. DNA.
I have a feeling it's hard to believe
Okay.
that such small things happen to us. Like, yeah,
It's
it is.
insane.
Jordan,
The cell is the most amazing thing on the planet. The things that go on inside it are unreal.
all at
Unreal.
the same time.